To understand deep learning, let's start with the fundamental building block, the artificial neural network, often called a feed-forward neural network or a multi-layer perceptron. We'll explore its architecture and how information flows through it. At its core, an ANN is composed of interconnected neurons, also called nodes. These neurons are organized into layers. We typically have an input layer, where our raw data enters the network. This layer doesn't perform computations. It simply passes the input values forward. Following the input layer are one or more hidden layers. These are where the magic happens. Complex computations and feature transformations occur. Each neuron in a hidden layer receives input from the previous layer, performs a calculation, and then passes its output to the next layer. Finally, we have the output layer. This layer produces the network's prediction or classification. The number of neurons in the output layer depends on the problem. One for binary classification or regression, multiple for multi-class classification. Now let's look inside a single neuron. Each input connection to a neuron has an associated weight. Think of weights as the strength or importance of that input. The neuron multiplies each input by its corresponding weight and sums these products. This sum is then added to a bias term, which allows the neuron to activate even if all inputs are zero, or shift its activation threshold. This weighted sum plus bias is then passed through an activation function. The activation function introduces nonlinearity into the network. Without it, stacking layers would just be like stacking linear equations, resulting in only a linear model. Common activation functions include ReLU, rectified linear unit, which outputs the input directly if positive, otherwise zero, and sigmoid, or softmax for outputs, squashing values between 0 and 1. The process of information moving from the input layer through the hidden layers to the output layer is called forward propagation. It's how the network makes a prediction for a given input. In summary, an ANN is a series of interconnected neurons, each performing a weighted sum of its inputs, adding a bias, and passing it through an activation function. This creates a powerful system capable of learning complex, nonlinear relationships. But how do these weights and biases get adjusted to learn? That's what we'll cover in our next lecture, backpropagation.